In Heads Pro, there are 3 methods to design roads: 1. Workspace method of interactive design, 2. Project data file method for batch processing, and 3. Text data files method, old classic method. Method 1, Workspace method of interactive design 1.4, multiple section highway widening. This method starts with one single file, which is the total station topographic survey data file survey.txt, and creates various reports, models, drawings, etc., and finally creates the project data file, which is the backup of all design data. In folder work 4 the whole process is available. To open the project, user may double-click the project tag design job number 1.htr inside folder as work 4 multiple section highway widening project. To process data in batch mode, method 2, user may copy the files survey.txt and project data file to a folder, may be created as work, and follow method 2 to select and process the project data file, by following the steps given in file guide for method 2, multiple section in project data file. To process data in workspace mode, method 1, user may copy the files survey.txt in a folder, may be created as work 4, and process the design by following the steps described stepwise in this session. Step 1. Open main screen of Heads Pro, by double-clicking on the desktop icon. Select menu item file, select working folder. Step 2. The folder is selected as exists, or user may browse and create and select a working folder work 4. Step 3. Select menu item, file new/open project workspace highway design suit new/open multiple section highway widening project. Step 4. Project workspace opens for multiple section highway widening project, click on button create project, the project folder will be created as design job number 01 inside user's working folder. Message comes confirming that the project folder will be created, click on OK. Step 5. Survey data option is selected as total station, click on button browse to select the total station survey data file that exists at any location. Step 6. Select the total station survey data file survey.txt, which may exist at any folder in some location. A copy of this file will be imported to user's project folder. Message comes confirming that a copy of this file is imported to user's project folder, click on OK. Step 7. Open tab window process survey data. In this tab there are 3 more tabs. The first tab is opened as Step 1, Ground Model, click on button create ground model. Step 8, as the process is over the message comes, click on OK. Step 9, the list of survey features comes. In column draw in the list, user may remove check mark for the feature to exclude it from the drawing, click on the color box for feature drain, select a desired color, click on button apply. Step 10, in similar way click on the color box for each feature and select a desired color for the respective feature, click on button apply. This way colors are assigned to all the survey features. Step 11, click on button draw at the bottom of the list of all features. Step 12, the ground model is drawn with all the selected features. Step 13, open tab window. Step 2, triangulation under the primary tab process survey data, click on button create triangulation model, the process dialog box comes, click on button proceed. Step 14, as the process is over the message comes mentioning about the output, click on button OK. Step 15, open tab window. Step 3, contour under the primary tab process survey data. By default the primary contour interval is shown as 1.0 m, the secondary contour interval is 5.0 m, which is always 5 times of the primary interval. In case of a flat ground the primary contour interval may be given as 0.1 mm and the secondary interval will be 0.5 m. The contour elevations will be written on secondary contours only to reduce the text overlapping. Click on button create contour model. Step 16, the process dialog box comes, click on button run. The contour window opens and shows the process of creating contours on the triangulation model. Step 17, as the process is over, click on the button save on top panel of the contour window. Step 18, next, click on yellow color contour icon at the bottom panel of the window. As the dialog box comes, click on the button quit to close the contour window. Step 19, next, we are back to the tab for contour in the project workspace, click on button draw contour model. Contours are being drawn and wait for some time. The contour model is drawn over the ground model, primary contours are drawn in gray color and secondary contours are drawn in orange color. Step 20, open tab window highway widening. In this tab there are 8 more tabs for steps 4 through 11. The first tab is opened as Step 4, Horizontal alignment. User may either select the option Process Halen Design Data, if the Halen data is available. Step 21, paste the Halen data in the lower left box. And by clicking on button Proceed, the Halen data will be processed and the model will be saved with center line string M001 under Model Name Design in Model Files. Step 22, or alternatively, user may select the option New Halen Design, and click on button Proceed to design the alignment interactively. Step 23, click on icon on the right side of the window for drawing a polyline, and click on a number of points on the contour drawing to draw a polyline. To finish the polyline, click the right mouse button. The polyline should pass through the center of the contours. The points should be sufficiently away from each other to accommodate curves to be set at these points. These points are called horizontal intersection points, HIP. Step 24, select menu item Design Alignment New HIP method. Step 25, click the left and then right mouse buttons on the polyline just drawn by the user. Step 26, the design dialog box comes. User may change the data as desired, click on button Apply. Step 27, message comes saying that the curve is large at a HIP, reduce the curve radius to 500 meters. Necessary lead and trail transition curves may be entered as per the design standard, click on OK. Step 28, similarly, upon clicking on button Apply each time, if some other curves are found large at other HIPs, then reduce the curve's radius as suitable. Necessary lead and trail transition curves may be entered as per the design standard. By minimizing the design dialog box, the alignment can be checked. Selecting menu item Design Shehnage on and Design Details on, the shehnage and details can be seen. Step 29, if no more message comes for large curves, then click on button Save and Finish. Step 30, next comes the dialog box for modeling the design. Select the string M001, click on OK. Step 31, the dialog box comes for modeling process, click on button Proceed. Step 32, as the modeling process is over, the message comes, click on OK, close the design window heads viewer. Step 33, now we are back to the window for step 4 in the design workspace. The Halen design data is displayed on the left side box, click on button View Halen Design. Step 34, click on the button View Halen Design, the dialog box comes, select string M001, click on OK. Step 35, the alignment with tangents and curves is drawn, this is just for viewing only. Step 36, click on button Shehnage on, the dialog box comes, select the string M001 and enter other details, click on OK. Step 37, the shehnages are displayed along the alignment of the road center line. Next, click on button Details on. Step 38, the dialog box comes, select the string M001 and enter other details, click on OK. Step 39, the curve details are displayed along the alignment of the road center line. Step 40, tab page Step 5 is opened. For different shehnage sections, desired typical cross-section type is assigned, followed by clicking on button Add. The intention is to create strings MEL1 and MEL2 on the left side and strings MER1 and MER2 on the right side, referring to string M001. Step 41, click on button Save Schedule Data and Process. Step 42, the message comes, click on OK. Step 43, the window comes with a list for batch processing a set of 4 items. To process each item in sequence, click on button Proceed. Step 44, for the first process the window comes, to create offset strings MLT1 and MLT2 on the left side and MRT1 and MRT2 on the right side, click on button Proceed. Step 45, as the process finishes, the message comes, click on OK. Step 46, for the next process the window comes to copy strings from MLT1 to ML01 and MRT1 to MR01, for making the strings ML01 and MR01 continuous, click on button Proceed. Step 47, as the process finishes, the message comes, click on OK. Step 48, for the next process the window comes to copy strings from MLT2 to ML02 and MRT2 to MR02, for making the strings ML02 and MR02 continuous, click on button Proceed. Step 49, as the process finishes, the message comes, click on OK. Step 50, for the fourth process the window comes to create EL01 referring ML01, click on button Proceed. Step 51, as the process finishes the ground long section string is to be created as EL01 under the string ML01, the message comes, click on OK. Step 52, as the process finishes the ground long section string is created as EL01, the message comes, click on OK. Step 53, next, the ground long section string is to be created as ER01 referring MR01, message comes, click on OK. Step 54, as the process finishes the ground long section string is created as ER01, the message comes, click on OK. Step 55, as all the four processes are over, click on button Finish OB the right side is shown, to close the window for batch process. Step 56, open the tab page. Step 6, under this tab page there are 3 more tab pages. Currently the tab page Vertical Profile Optimization data is open, the various default data are mentioned, user may change the data as desired in the authorized version of Heads Pro. Step 57, in the first process, by following the ground long section string EL01, a string for optimized vertical profile with 0.14 m thickness for pavement overlay will be created as MEL1 on the left side, click on button Proceed. Step 58, as the process dialog box comes, click on button Proceed. Step 59, as the process is over the string is created as MEL1 on the left side, the message comes, click on OK. Step 60, in the second process, by following the ground long section string EL01, a string for optimized vertical profile with 1.40 m thickness for pavement will be created as MEL2 on the left side, the process dialog box comes, click on button Proceed. Step 61, as the process is over the string is created as MEL2 on the left side, the message comes, click on OK. Step 62, in the third process, by following the ground long section string ER01, a string for optimized vertical profile with 0.14 m thickness for pavement overlay will be created as MER1 on the right side, click on button Proceed. Step 63, as the process is over the string is created as MER1 on the right side, the message comes, click on OK. Step 64, in the fourth process, by following the ground long section string ER01, a string for optimized vertical profile with 1.40 m thickness for pavement will be created as MER2 on the right side, click on button Proceed. Step 65, as the process is over the string is created as MER2 on the right side, the message comes, click on OK. Step 66, now, all the 4 processes are over, click on button Finish on the right side to close the window for batch process. Step 67, within tab Step 6, open the next tab page Design Vertical Profile, via line, click on the button Draw Ground Long Section, the dialog box comes, the default horizontal and vertical scales are mentioned, click on OK. Step 68, the strings EL01 and ER01 for ground long sections on left and right sides of the proposed center line are drawn, the vertical profile design data for string ML01, whose horizontal alignment is already designed, is imported and displayed on the left side panel, and click on button Proceed. Step 69, the process dialog box comes, click on button Proceed. Step 70, the data is processed, vertical profile of the carriageway center line on the left side in created, message comes, click on OK. Step 71, the vertical profile design data for string MR01, whose horizontal alignment is also already designed, is pasted, imported and displayed on the left side panel, and click on button Proceed, the process dialog box comes, click on button Proceed. Step 72, the data is processed, vertical profile of the carriageway center line on the right side in created, message comes, click on OK. Step 73, now click on button Draw Vertical Profile, to draw the designed vertical profiles of strings ML01 and MR01. Step 74, the dialog box comes, select string ML01, the scales in X and Y directions are mentioned as 1 to 10, click on OK. Step 75, the dialog box comes, select string MR01, the scales in X and Y directions are mentioned as 1 to 10, click on OK. Step 76, the designed vertical profile for the center line of the left and right carriageways are drawn, click on button Grid On. Step 77, the dialog box comes, the default data are mentioned, click on OK. Step 78, the grids are displayed in 1 to 10 scale over the designed vertical profile of the left and right carriageway center lines, shenages are displayed at the bottom and elevations are displayed at the left vertical side. Step 79, click on button Vertical Details On, the dialog box comes, select a string, here string ML01 is selected, click on OK. Step 80, the design details for vertical profile for string ML01 are displayed, after viewing click on button Vertical Details Off and again click on Vertical Details On, in dialog box select string MR01, click on OK. Step 81, the design details for vertical profile for string MR01 are displayed. Step 82, next, open the tab page. Step 7, define the dimensions of various cross-section elements. There are 3 tabs under the current tab. The tab Define Cross-Sections is opened, select a range from the list as the schedule No, the default data for the dimensions are given, user may change the data as desired, in unauthorized version the change in data is not accepted. Step 83, click on the button Save Data, the message comes, click on OK. Step 84, next, we open the tab page interface to define the slopes and berms, the details of the data is given, user may change the data as desired, the data is explained in Help on the main screen of Heads Pro. Step 85, next, we open the tab page Create Cross Sections, click on button Process Cross Section Data. Step 86, the process window comes with various design items, each one is to be processed one after another in sequence, click on button Proceed. Step 87, the first process starts to create 3 strings CL01, CL02, CL03 on the left side and strings CR01, CR02, CR03 on the right side forming the central median, click on button Proceed. Step 88, as the process is over the message comes, click on OK. Step 89, the next process is to modify the model for internal system requirements, the process dialog box comes, click on button Proceed. Step 90, as the process is over the message comes, click on OK. Step 91, the next process will create the super elevated left carriageway edge as string CL04 in the model files, the process dialog box comes, click on button Proceed. Step 92, as the process is over the message comes, click on OK and Finish. Step 93, the next process will create the super elevated right carriageway edge as string CR04 in the model files, the process dialog box comes, click on button Proceed. Step 94, as the process is over the message comes, click on OK and Finish. Step 95, the next process will create the super elevated left paved shoulder edge as string CL05 in the model files, the process dialog box comes, click on button Proceed. Step 96, as the process is over the message comes, click on OK and Finish. Step 97, the next process will create the super elevated right paved shoulder edge as string CR05 in the model files, the process dialog box comes, click on button Proceed. Step 98, as the process is over the message comes, click on OK and Finish. Step 99, the next process will create the left and right edges of the earthen shoulders as string CL06 and CR06 and made them continuous as string CL07 and CR07 respectively in the model files, the process dialog box comes, click on button Proceed. Step 100, as the process is over the message comes, click on OK. Step 101, the string EL07 for ground long section is to be created under the left offset string of the 2 offset strings which was just created in the previous step, click on button Proceed. Step 102, the message comes as displayed, click on OK. Step 103, as the process is over the ground long section string EL07 is created, the message comes as displayed, click on OK. Step 104, the string ER07 for ground long section is to be created under the right offset string of the 2 offset strings which was just created, click on button Proceed and as the message comes click on OK. Step 105, as the process is over the ground long section string ER07 is created, message comes as displayed, click on OK. Step 106, referring to the ground long section string on the left side just created another additional pair of offset strings SL05 and SR05 are to be created on the left and right ends for the end elements in a cross section in the schedule, for service roads, click on button Proceed. Step 107, as the process is over, the two offset strings SL05 and SR05 are created, message comes, click on OK. Step 108, the next process will create the cross-section of the road formation without the side slopes, click on button Proceed. Step 109, the message comes as shown, click on OK. Step 110, another message comes as shown, click on OK. Step 111, as the process is over, the cross-sections without side slopes are created in text files hds002.fill, the message comes as shown, click on OK and finish. Step 112, in this step the cross-sections at various shennage ranges are joined/updated, message comes, the process dialog box comes, click on button Proceed. Step 113, temporary strings are created as TL05 and TR05, message comes, click on OK. Step 114, once again cross-sections will be created, process dialog box comes, click on button Proceed. Step 115, the message comes, click on OK. Step 116, next message comes, click on OK. Step 117, as the process is over, the message comes, click on OK. Step 118, in this process the cross-sections are updated, process dialog box comes, click on button Proceed. Step 119, in this step the cross-section of the road formation will have slopes on left and right side by interface, the process dialog box comes, click on button Proceed. Step 120, the message comes, click on OK. Step 121, as the process is over, the message comes, the full cross-sections are created in file hds003.fill, click on OK. Step 122, as all the processes are over, click on button Finish at the right side as shown. Step 123, the dialog box comes with list of all strings, click on button Draw Strings. The strings are being drawn, please wait. Step 124, the strings are drawn, click on button Create cross-section drawings on the left side of the window. Step 125, the cross-sections are being drawn, please wait, these are for viewing only. Step 126, select a shennage as shown to view the cross-section, and the cross-section at that particular shennage will be displayed. Step 127, user has to check the cross-section at that shennage on the left side, with the plan view as displayed on the right side of the window. Step 128, the tab page Step 8 is opened for defining pavement layers. Inclusion of pavement layers is important because the thickness of the layers may result in cut at a cross-section, while the section may initially be in fill. Click on button Define Pavement Layers. Step 129, the dialog box comes with default data for various pavement layers. Select each cross-section from the schedule of cross-sections by serial number to the existence of service roads of elevated structure, and to define pavement layers accordingly. The values for HO and VO are mentioned as start and end distances of each layer with respect to the road center line. User may change the HO and VO values as desired. Select range 1 of the schedule No. Define layers, click on button Save. Step 130, select each range of shennages of the schedule No. Define layers, finally click on button Save. Step 131, the message comes as shown, click on buttons OK and Finish. Step 132, we are back to tab Step 8 in the workspace. The pavement layers data is displayed on the left side, click on button Process Data. Step 133, the process dialog box comes, click on button Proceed. Step 134, the message comes as shown, click on OK. Step 135, as the process is over, the message comes, click on buttons OK and Finish. Step 136, the tab page Step 9 is opened for volume to compute the quantities for earthwork and pavement layers, click on button Process Data. Step 137, the process dialog box comes, click on button Proceed. Step 138, as the process is over, the message comes, click on buttons OK and Finish. Step 139, the result is displayed on right lower panel, and the report is written in file volume.rep. Step 140, the tab page Step 10 is opened. Under this tab there are 4 more tabs. Currently the tab Alignment Schematics is open to create the drawings for schematic drawings for horizontal and vertical alignments. Click on button Process Data. Step 141. The process starts to create schematic drawing for the horizontal alignment and the dialog box comes. Click on button Proceed. Step 142. As the process is over, the message comes. Click on buttons OK and Finish. Step 143. The next process starts to create schematic drawing for the vertical alignment and the dialog box comes. Click on button Proceed. Step 144. As the process is over, the message comes. Click on buttons OK and Finish. Step 145. Next, the tab Page Plan is opened, that exists under the tab Page. Step 10. To create the plan drawing, the various data is given, user may change the data as desired. Refer to Heads Pro main screen help to understand the data. Click on button Process Data. Step 146. The process starts to create one single plan drawing or a set of plan drawings at an user given Schenage interval. This is described in the Heads Pro main screen help. The dialog box comes. Click on button Proceed. Step 147. As the process is over, the message comes. Click on buttons OK and Finish. Step 148. Next, the tab Page Profile is opened, that exists under the tab Page. Step 10. To create the profile, long section, drawing, the various data is given, user may change the data as desired. Refer to Heads Pro main screen help to understand the data. Click on button Process Data. Step 149. The process starts to create one single profile drawing or a set of profile drawings at an user given Schenage interval. This is described in the Heads Pro main screen help. The dialog box comes. Click on button Proceed. Step 150. As the process is over, the message comes. A set of 4 profile drawings are created at an user given Schenage interval of 1000 meters. Click on buttons OK and Finish. Step 151. Next, the tab Page Cross Section is opened, that exists under the tab Page. Step 10. To create the cross section drawing, the various data is given, user may change the data as desired. Refer to Heads Pro main screen help to understand the data. Click on button Process Data. Step 152. The process starts to create one single cross-section drawing or a set of cross-section drawings at an user given Schenage interval and drawing sheet size. This is described in the Heads Pro main screen help. The dialog box comes. Click on button Proceed. Step 153. As the process is over, the message comes. A set of 20 cross-section drawings are created at an user given Schenage interval. Click on buttons OK and Finish. Step 154. The tab Page Step 11 is opened in the Design workspace. Under this tab there are 6 buttons. Click on the button Create/Update Project Data File. Step 155. The project data file is created and the message comes. Click on OK. Step 156. Click on the button Open Project Data File. The project data file is displayed on the screen and is also opened in Notepad to take printouts. This is the backup file of the design data and may be processed along with the total station survey data file by taking these 2 files in a new folder, and by using project data file method for batch processing as mentioned at the start of this session. Step 157. Click on the button View Survey Data File. The total station survey data file is opened in Notepad to view or to take printouts. Step 158. Click on the button View Report Files. Step 159. The window opens with a list of report files on the left side. Select a report and the report file is displayed to view or to take printouts. Step 160. Click on the button View Drawings. Step 161. The message box comes. Click on button Yes. Step 162. The Heads CAD viewer opens with a list of various drawings created inside a folder Design Drawings. Inside the project folder that was created at the start of this session under the working folder select by the user, select a drawing in the list and the drawing is displayed to save or print. After viewing the drawings, close the CAD viewer without saving the drawings. In unauthorized version of Heads Pro the drawings cannot be saved or printed. Step 163. By clicking on the button Open Viewer, user can open the Heads CAD viewer. Step 164. We are again back to the tab Page Step 11 of the project workspace. Close the project workspace. The message comes asking whether to save/update the project data file. Click on button Yes. Step 165, the message comes, click on OK. This is the end of session 4 method 1, workspace method of interactive design 1.4, multiple section highway widening.